right, let's look at another example in section 15.5 where we're finding the area in between two curves. Example number 2 asks us to find the area in between the curve y equals x to the 1/2. If you don't like it as a rational exponent, remember x to the 1/2 is really another way of saying y equals the square root of x. And then we want to also find the area between that one and the function y equals x cubed. Now, I don't know about you, but it's much easier for me to visualize what's happening with these two functions if I can sketch a graph. So what does the graph of y equals the square root of x look like? Well, I know it's going to kind of start at 0, and it's going to kind of, I don't know where I got this from, but breadstick up, right? When x is 1, we get 1. When x is 4, we get 2. And so it's going to kind of go up, but then slowly go up as you increase on the x, right? And so there's my y equals x to the 1/2, or y equals square root of x graph. The graph of x cubed kind of looks like a little snake, right? It goes down, it crosses at 0, and then it kind of goes up like this. So you should really have a good idea what these functions look like so you can kind of sketch the graph of these functions. They don't have to be exact, but you guys should have an idea of what they look like without necessarily putting it in your calculator. So when it asks me to find the area in between these two curves, I know I'm talking about that little green shaded area. And so you might notice that we have some intersection points. We have two places where these two graphs are going to cross. If you're not sure exactly where they're going to cross, what we need to do to figure out those intersections, remember this is our first step, is we've got to take these two equations and we've got to set them equal to each other. I want to figure out where they intersect so I know where I want to start and where I want to end when finding the area in between these two curves. What are my A and my B going to be for my limits of integration? So let's take these two equations and let's set them equal to each other. So I have x to the 1/2 is equal to x cubed. All right, now we need to solve. What I'm going to do from here is I'm going to move all of my x's to the same side. So you might notice that I subtracted my x to the 1/2 to the other side. I also notice that I have x's in both, and I want to factor out a greatest common factor, but the most I can factor out is an x to the 1/2. When I factored out an x to the 1/2, that left me with x to the 5/2 minus 1. Remember, when you multiply, you really add the exponents, so that helped me figure out what the 5/2 was. If I started off with a 6/2, isn't that 3 with a common denominator? All right, and so now that I have it factored, I should be able to set each of these factors equal to 0. When I set the x to the 1/2 equal to 0, I can square both sides so that the square and the 1/2 will cancel. And so I end up with x equals 0. When I set the x to the 5/2 minus 1 equal to 0, I can add 1 to both sides, and then I can actually raise it to the 2/5 power. That will get rid of the 2 and the 5, and so I'm just left with an x equals, right? And 1 to the 2/5 power is really just 1. So you might notice from my sketch that they intersect at 0 and 1 exactly. And without me putting those numbers, that was the only way that you're going to be able to figure out where they intersect, is you have to do the algebra in order to figure out where they intersect. You've got to set them equal to each other so that we know for sure that they intersect at 0 and they intersect at 1. And so we want to find the area in between 0 and 1. So those are going to be my limits of integration, 0 to 1. If we're finding the area in between, we want to figure out which one's our top function and which one's our bottom function, right? Now, you might be able to see on the picture that our top function is really going to be my x to the 1/2, and my bottom function is going to be x cubed. But if you weren't sure, or if you didn't have a picture, what you could always do is pick any number in this interval from 0 to 1, I don't know, maybe 1/2, and plug it into each function and see which one was going to give you the highest value. The highest value is going to be the function that's on top, okay? So if we want to do top minus bottom, my top function is the x to the 1/2 minus my bottom function, which is x cubed. So now I can find the area in between these two curves, these two functions from 0 to 1 by setting up this integral. Let's use our integration techniques. I have x to the 3/2 divided by 3/2, or multiplied by the reciprocal, 2/3, minus x to the 4th over 4 and I want to evaluate it from 0 to 1. That means I want to use my fundamental theorem of calculus, and I want to plug in my upper limit, plugging in a 1, and I want to plug in my lower limit, plugging in a 0, and subtract the two, making sure that you're organized and neat, and I can see all of your work so I know exactly how you got it, and I know you didn't just use your calculator to have it spit out an answer, but I can see each of these steps so you can get full credit on your exams. I want to be able to see that you're setting up the appropriate integral, that you're using your integration techniques, and that you're evaluating using your fundamental theorem of calculus, okay? All right, plugging in our 1, plugging in our 0, I ended up getting 2/3 minus 1/4 for that first parentheses. 0 was in my second parentheses, so that kind of just went away over there. Getting a common denominator of 12, and I was able to get an answer of 5/12. So I know the exact area in between these two curves from 0 to 1 is 5/12. Making sure I figured out the intersection points by setting them equal. Making sure I figured out which one was my top function versus my bottom function, and then setting up an integral so I can integrate top minus bottom from A to B.